In the last lecture module, we considered partial potential models, one outcome or one way in which scientists extrapolate a paradigm from a paradigmatic case and structure a domain around that paradigmatic case. In this lecture module, we want to turn our attention first to generalized solution strategies and then to explanatory schemas. As part of the process of extrapolating a paradigm from a paradigmatic case and structuring the domain around that paradigm and paradigmatic case, researchers also develop problem categorizations as well as techniques for adapting and manipulating their theoretical models. I refer to these as generalized solution strategies, and they allow scientists to better utilize those models to generate predictions, retrodictions, manipulations, and explanations across a wider range of applications and with less cognitive effort. An example that we used in the chapter was the use of component vectors to simplify basic physics problem solving. In this case, we want to understand the motion of a block as it moves down an inclined plane. We have gravity acting on the stone to move the stone, but gravitational force is neither perpendicular to the surface of the inclined plane, nor is it aligned with the direction of movement of the block down the plane. In order to simplify the solution of this problem, physicists standardly break up, quote unquote, the gravitational force exerted on the block into two components. One component helps us to understand the drag created by the frictional coefficient and the gravitational force pressing the block down on the surface of the plane. The other component helps us understand the movement of the block down the inclined plane as a result of the gravitational force exerted on the block causing it to move. This decomposition of forces into these component vectors simplifies and standardizes the solution of such problems. In a similar fashion, as scientists extrapolate the paradigm and structure the domain around paradigmatic cases, theorists begin to develop a general framework, a general schema for predicting, retrodicting, manipulating, and explaining phenomena in that domain. Thus, explanatory schemas start to emerge and they serve to delineate and structure the domain. They represent the central insight into the domain's phenomenon. Examples of explanatory schemas that emerge during the extrapolation of a paradigm and the restructuring of a domain in our textbook include the pendulum law being used to extrapolate out the domain of periodic motion, and the example of temperature as kinetic energy that was the explanatory schema that emerged early on in classical thermodynamics. Since explanatory schemas serve to delineate and structure a domain, and since they represent a or the central insight into the phenomenon, if theorists' understanding of the central insight of a domain changes, then the domain will often change to reflect this new understanding. For example, the domain incorporating the ideal pendulum law changes as theorists shift the explanatory schema from uniform gravitational acceleration to periodic motion, from periodic motion to harmonic motion, and finally from harmonic motion to oscillating systems theory. This change of explanatory schemas reflects the change in the primary way in which theorists are understanding the phenomenon and gathering them together within the domain under the umbrella of the paradigm.